Hello friends, and welcome to Pathologic Volume 4, Episode 12. Today's puzzle is a Mejilink, and let's take a look at the rules. The rules of Mejilink are: trace some of the given borders to draw a non-intersecting loop. That part is pretty straightforward. We are just going to make a loop in the grid like we do in many puzzles, going orthogonally, vertically and horizontally around the grid, but with the slight twist that the potential borders are given by these dotted lines. We can't jump across the gaps. It's just got to be on these borders. The number of cells in a region must equal the number of borders surrounding it that don't belong to the loop. This part was really confusing to me when I read this the first time, and took some time for it to sink in. So let me see if I can explain it with the example solution. So for example, this 5-cell region here, 1, 2, 3, 4, 5, means that there will be 1, 2, 3, 4, 5 segments of its border that are not part of the loop. So when it's saying border, it just means one small chunk between two dots, not the entire contiguous line like I first interpreted that. Another example here, this big one is 1, 2, 3, 4, 5, 6, 7 large, so we know that there will be 7 of its borders, 1, 2, 3, 4, 5, 6, 7, that are not part of the loop. The word don't is very important here. Those are the rules of Mejilink. So it's time to solve a puzzle. Today's Mejilink puzzle was set by Jovial. Looking at, I'm not entirely sure where I am going to look in a puzzle like this, other than 1-cell regions seem pretty straightforward. We know that there is exactly one of the 4 borders that is not part of the loop. So let's start with this corner up here. This region needs to have one not part of the loop, and it couldn't be either of these in the corner because then the loop would dead end. So both of these are part of the loop. And the same goes with this corner. I'm used to looking at corners of the grid, but because of the sizes of these regions, we've got corners in other places too. So exactly the same logic means that these are part of the loop. And this couldn't continue north from there because then our loop would close prematurely. So this is not part of the loop, which means this is a little bit of an S. This continues on like this. Now let's look at the size of this region. 1, 2, 3, 4, 5, 6, 7 cells are not part of the loop. We have 1. We need 6 more, and there are 6 more. So those are all out. The loop continues this way. Let's look at this corner. 1, 2, 3, 4, 5, 6, 7, 8. How are we gonna do that? We've got a 1, 2, 3, 4, 5 cell, 3, 4, 5, and a 6 cell. One of those two will be out, and some subset of this. I don't think we know which yet. This region only has 4 cells that are not part of the loop. It's going to be either these, let's see, if it was this section, 1, 2, 3, there's no single, I don't think. Is that true? Correct, because if this was out, this would be in, and we wouldn't be able to finish up the 4. So these 4 are the 4 that are not part of the loop. The rest of this shape is. This must continue down this way. We've got 1, 2, 3, 4, 5, 6 X's to place here, and I think that's what we have left. 1, 2, 3, 4, 5, 6. Good. The loop has to continue this way. Here we need 1, 2, 3, 4, 5, 6, 7, 8. And that's how much, wait, no, we've got 1, 2, 3, 4, 5 of them already. We can only do 3 more if this if any of this was out, all of it would be, and that'd be 4 more. Can't have that. We need 3 more, which is going to be these 3, because this is a 1 by itself, so that's got to be in. Now that's already told us that these 4 are out, and that matches the size of this region, 4. The loop has to continue over here, and is going to have to finish up there. Let's, before we do that, just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 matches 3, 4, 5, 6, 7, 8, 9, 10. And 1, 2, 3, 4, 5, 6, 7, 8 matches 1, 2, 3, 4, 5, 6, 7, 8. So we can just join it up right here. And that is how we solve a Mejilink.